GeopByte.
Dear students, now let us discuss the previous year questions for the very important and easy unit, that is motion in a straight line is also called motion in one dimension. Okay, from this very easy unit, minimum one question can be expected, maximum two questions can be expected for the NEET. Okay, I hope all of you clearly understood all the theory concepts what we discussed for motion in one dimension. Understood or not? Yes. Then let us take the very first question. Look at the very first question asking like this. A particle is moving along x-axis with its position x varying with time. Look at the x in terms of time. The displacement x equal to alpha t power 4 plus beta t square plus gamma t plus delta. The ratio of its initial velocity to initial acceleration. It is asking to decide. It is asking to decide what is the ratio between initial velocity, and initial acceleration. Initial acceleration equal to how much? For that, we need to decide the velocity first. As you know, velocity v equal to dx by dt, rate of change of displacement. Let us simplify it. It is equal to 4 alpha, simple mathematics, t cube plus 2 beta t plus gamma. Similarly, acceleration a equal to what? dv by dt. It is equal to, right? So dv by dt, it is equal to d by dt 4 alpha t cube plus 2 beta t plus gamma. Simplify this value. It is equal to 12 alpha t square plus 2 beta plus differentiation of constant is 0. Okay. Then for initial velocity, for initial velocity, for initial velocity, as you know, the time t equal to 0. Then what is the v initial? V initial equal to time t equal to 0. Right? First two quantities become 0. It is equal to gamma. Similarly, for initial acceleration, for initial initial acceleration also, time t equal to 0. Then this quantity is becoming 0. Therefore, the initial acceleration equal to 2 beta. Therefore, initial velocity by initial acceleration equal to, it is equal to gamma by 2 beta. That is the answer. Gamma by 2 beta. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Then let us take the another important problem. It is asking like this. Look at the question. The velocity versus time plot for the motion of a body is shown below. Look at the velocity versus time graph. A, B, C, D is representing the velocity versus time graph. The acceleration versus time graph that best suits for this motion. That means the same diagram with acceleration versus time graph is asking. As you know, acceleration, acceleration, acceleration A equal to rate of change of displacement dv by dt. Okay. Look at the diagram for AB, for A to B in this region. A to B, velocity is increasing along with the time. That means velocity and time both are increasing. Then acceleration A equal to what? dv by dt. Since velocity is increasing, dv positive along with the time, dt positive. Since dv and dt, here dv positive, dt also positive. Since dv and dt positive, acceleration is positive for the A to B. That means in this region, in this region, positive acceleration can be found. Similarly, look at the CD for CD. Of course, for the BC, since it is maintaining constant acceleration, constant velocity, acceleration is zero. For C to D, for C to D, look at the diagram. Velocity decreasing along with the time. That means while the time is increasing, velocity decreasing. Then acceleration equal to what? dv by dt. Right? Here velocity decreasing means dv negative. Velocity decreasing means dv negative. dv negative, but time dt is positive. Since dv negative, dt positive, the acceleration is negative. Acceleration is negative for the C to D. Now look at the options. Look at the option B. In this region, positive acceleration can be found, and in this region, negative acceleration can be found. Therefore, you can select the option B. Option B is absolutely correct. I try to explain the each and every point at your better understanding level. Understood or not? Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. Two heaters A and B have power rating of 1 kilowatt and 2 kilowatt respectively. Given that power rating of A is 1 kilowatt, power rating of A is 1 kilowatt, and power rating of B is given 2 kilowatt. Those two are first connected in series and then in parallel to a fixed power source. They are connected first in series like this. This is the series arrangement with RA and RB, and parallel arrangement with RA and RB. Okay. Then the ratio of power outputs for these two cases is, that means he is asking power output with the series arrangement dividing by power output with the parallel arrangement. Okay. For that, we should know the relation between the power and resistance. As you know, power P equal to V square by R. From this, I can write that P into R equal to V square. It is given that they are connected for the correct same power source, V constant. Therefore, V square is constant. Since V square is constant, I can say that product of P and R equal to a constant, or PA RA equal to PB RB. From this, I can write that PA by PB equal to RB by RB by RA. Look at the PA 1, PB 2 equal to RB by RA. From this, RA equal to, listen carefully, 2RB. 2RB. That is the relation between the RA and RB. Okay. Then for the series arrangement, how do we write the power for the series arrangement? For this particular arrangement, power in the series arrangement equal to V square by equivalent resistance for the series arrangement. Okay. What is the equivalent resistance for the series arrangement? RA plus RB. Okay. Look at the RA. RA equal to 2RB plus RB. It is equal to 3RB. That is the equivalent resistance for the series arrangement. Then it is equal to power with the series arrangement equal to V square by equivalent resistance with the series arrangement is 3RB. Understood clearly? Yes. Similarly, let us take the parallel arrangement. For this parallel arrangement, the power for the parallel arrangement is V square by equivalent resistance for the parallel arrangement. For the parallel arrangement, 1 by equivalent resistance equal to 1 by RA plus 1 by RB can be written as RB plus RA divided by RA RB. From this, I can write that equivalent resistance for the parallel arrangement equal to RA RB by RA plus RB. RA plus RB. But what is the RA value? Look at the RA value. RA equal to 2RB. It is equal to 2RB whole square by RA equal to 2RA plus RB. Now you simplify it. It is equal to 2RB square divided by 3RB. 1 RB is cancelling. 1 RB is cancelling. Finally, it is equal to 2 by 3. 2 by 3 RB. That is the equivalent resistance. It is equal to V square by 2 by 3. 2 by 3 RB can be written as 3 by 2 V square by RB. Right? E square by RB. Then power output for the series arrangement divided by power output for the parallel arrangement. Power output for the series arrangement equal to what? V square by 3RB. It is V square by 3RB dividing by, for the parallel arrangement, 3 by 2 V square by RB. Now you simplify it. It is equal to 2 by 3 into, right, 2 by 3 into V square by RB divided by 3 into V square by RB, right? This part is cancelled. Finally, it is equal to 2 by 3 into 3 equal to 2 by 9. That is the power outputs for the series arrangement divided by power output of the parallel arrangement. 2 is 9. Look at the options. Look at the option A. Option A is absolutely correct. I hope all of you clearly understood. Understood or not? This is very, very important problem. Okay.
GeopByte.